about what we are building for the future. At I/O earlier this year, we talked about our vision for that future. We're at a seminal moment in computing. If you step back and think about it, computing has always had big shifts every 10 years or so. It all started in the 80s, early 80s, when the personal computer reached the mainstream. It was the first time computing touched the lives of many people, revolutionized the way they work. Roughly a decade later, in the mid-90s, the web arrived. It is arguably the biggest platform shift we have seen in our lifetimes. It brought the internet to many more people, radically changed industries, fundamentally changed how people interact and connect with each other. About 10 years later, in the mid-2000s, with the advent of smartphone, we had the mobile revolution. That brought computing to probably now around half the world's population. And it's profoundly changing people's lives. And the shift continues. In fact, when I look ahead at where computing is headed, it's clear to me that we are evolving from a mobile-first to an AI-first world. What do I mean by that? In this world, computing will be universally available. It'll be there everywhere in the context of a user's daily life. People will be able to interact with it naturally and seamlessly than ever before. And above all else, it will be intelligent. It'll help users in more meaningful ways. At Google, we are very, very excited about this shift, and we've been working for a long time towards this shift. At the heart of these efforts is our goal to build a Google Assistant. We spoke about the Assistant earlier at Google I/O this year. We envision the world's attention when DeepMind's AlphaGo won the World Go Championship against laser, machine translation, image recognition, and voice recognition systems. And each of these areas is being turbocharged by the progress we are seeing with machine learning and AI. A few months ago, we captured the world's attention when DeepMind's AlphaGo won the World Go Championship against Laser, one of the finest players of our generation. It showed the external world the moment for AI has arrived. But for us, the progress has been continuous, and the strides are huge. In fact, in the 3 months since AlphaGo played that game, we have had meaningful launches and how machine learning is impacting the products we build. Let me talk about 3 examples, all of which we have talked about in the past 3 months since the AlphaGo moment. First, image captioning. Image captioning is how computers try to make sense of images they look at. And we first launched our machine learning system in 2014. It was a state-of-the-art system, and our quality was around just over 89%. Our newer machine learning systems now, the quality is close to 94%. 4% may not sound like much to you, but first, it's really hard to increase quality at these levels because we are trying to approach human level accuracy. And second, every single percentage point translates into meaningful difference for our users. So for example, if you take a look at the picture behind me, about 2 years ago, we used to understand this picture as a train is sitting on the tracks. Now, we understand the colors, so we describe it as a blue and yellow train is traveling down the tracks. Or if you look at this picture, 2 years ago, we understood it as a brown bear is swimming in the water. Now, we can count, our computing systems can count, so we understand this as 2 brown bears sitting on top of rocks. Advances like this is what helps us when you're in Google Photos find the exact pictures you're looking for and be a better assistant to you. Another example, machine translation. We've been doing machine translation for a while. And historically, our systems are statistics-based, and we translate at a phrase-by-phrase level. So we
Hey guys, hope you enjoyed the video of Sundar, and we'll be building a neural network which Google has been building, and they have open sourced the network, that is the neural network model which they have built, and will be building a neural net of our own from that neural net, and getting data out of pictures which you see every day. So let's get started with the coding part of the tutorial. As this is an introductory video, there won't be much code. In the next video, I'll be showing how to install Anaconda, Jupyter, and other libraries for the execution of machine learning. I have already started the Jupyter notebook. You can start Jupyter notebook by typing the command Jupyter notebook from your command prompt. So Jupyter notebooks actually work from your browser, and it's majorly for Python. You can also use R for it. Python code is written in these blocks, and this can be executed by hitting shift and enter together. So in this video we'll be seeing how the open sourced code and libraries of ImageNet, which gets the classified output of items present in an image. So this is the website of ImageNet. Be sure you can look at it and download whatever things you want. So ResNet is from ImageNet. Keras is another library used for deep learning, which is built on Python, which will be taking an in-depth look throughout this series. Keras is actually a higher level of TensorFlow, which is the holy grail for deep learning. So shift and enter. This has been executed. ResNet is another class from the ResNet library. We'll be loading ImageNet weights. What are these weights and everything, you'll get clarity after watching few videos in this playlist. So again, execute. So this ResNet is a class in this ResNet 50 library. We are instantiating an object called model of this ResNet class. The machine in machine learning is this model. So what are we going to do is train this model basically to learn what the things have been shown to the model. While as you have observed, this 11, the thing before this 11 was a star. The star says that your code is being compiled. Please wait for a while. Once you get to see the digits, you are being said that the code has been successfully compiled and executed. We are using NumPy. NumPy is another library built in Python, which says that which basically deals with arrays and other stuff. What is it? You'll get to know again. So we are taking an photo of le.jpg. le.jpg is this one. So we are trying to classify and predict what is the data or the value from this image. So we have given the path le.jpg. Image.loadImage is from ImageNet utils. You are giving the path. You are converting. Okay, sorry. Image is from Keras. You are converting the image, that is the image of elephant that you just saw, into an array, and then you are basically pre-processing it. The machine which you have instantiated here, it has a method called predict, and X is the image that you have given. So you are predicting whatever the machine learns from the image. So it's getting compiled, and it has said that it can see the tusks of the elephant, and then it says that it is an African elephant. It also says that it can be an Indian elephant, the probability of being Indian elephant is 0.08, whereas of being African elephant is 0.32. Arabian camel, which is e power minus 8 probability. Okay, let me give another image. Let's give mine. Okay. Okay. Let's see what it predicts. Okay, it is predicting I have won a trench coat. A trench coat and a military uniform, it seems, a stretcher, a soccer ball. Where did it see a soccer ball? I don't know. A shovel, it seems. What is a shovel? Okay, so this is how basically you do machine learning. You'll get to know everything in detail if you watch the complete playlist. Thank you for seeing the whole video.